Good afternoon, students. I would like to discuss different topics of this C programming through some PowerPoint presentation. And using the PowerPoint presentation, I'll share some videos that may be helpful for you to understand. The videos will like a virtual class through which you can understand the different topics of C programming. Actually, the Oxford University Press have shared some teaching materials with me through which I will discuss this topic. One book by the Oxford University which covers most of the topics of our syllabus. I'm going to that uh, particular book. The book is by uh, Rima Thereja, who is the professor at the college at Delhi University. Which is the name of the book is Programming in C. And if we look into the syllabus of that book, the content of the book, so here we can see that there are 13 chapters, 15 chapters of this book. So mostly we required up to chapter number 10. So each chapter will be discussed in different PowerPoint presentation. Okay. So for each chapter, I'll have one PowerPoint presentation. I'll discuss through. I'll discuss the PowerPoint presentation through a video. For each chapter, I will create one video. So you are requested to go through the videos and try to understand the different topics of the C programming. Though you have done a lot of things, a lot of programs you have, so still some of you have doubts about these different topics and different points of this uh, C programming. That say suppose in arrays you have some doubts, in strings you may have some doubt. So you are requested to go through the videos. I hope it will help you a lot. So without further delay, going to that PowerPoint presentation. So this is our PowerPoint presentation. Now the book is Programming in C by Rima Thereja, and this is the chapter number 1. So introduction to the programming. Okay. Now for starting off with programming, we must have to know that what is computer. So a computer is a simple term can be defined as an electronic device that is designed to accept data, perform the required mathematical and logical operations at high speed, and output to the result. So a computer accepts data, processes it, and produces information. So we have to have some data, we have some objective, uh, or we have some problems that through which the data need to be processed, and after processing the data, there must be some result given by the computer. So this thing is done by this electronic devices, which is known as the computer. Now, a computer is an electronic device basically perform major operations. This is the block diagram of a computer. So I hope some of you have remembered this as I have discussed during the first or second class uh, in this second semester. So this structure have been discussed uh, in the basic structure of the computer. So these are the different parts of the computer. So some of the input parts, some of the output parts, some of are the storage device, and another part is known as the CPU. The CPU is basically the does the main control and processing parts. So there is control unit, and this arithmetic and logical unit will do the data processing. Now, input, output, and storage device I will discuss during the next one or two slides. In this picture, that the arrow sign indicates the flow of data and instruction, and these dotted lines, dashed lines, are the control exercised by the control unit. So the control unit have the control over the uh, input data, how it will be stored, and the output result, how it will be executed, and the total execution will be controlled by this control unit. Now, when we talk about computers, we actually mean two things. The first thing is that the computer hardware. What is the components of the computer system? One is computer hardware and another is computer software. So these two parts, if we draw a diagram, these two parts, hardware and software. Now the software can be divided into the system software and application software. We will come to those discussions or the different um, parts of this computer hardware and computer software later in few slides. Now come to the hardware part. So there are memory elements. So it can be RAM, it can be ROM, or it can be hard disk, type HDD, which is short we termed it as HDD. So these are the memory elements. Now we HDD also termed as disk. Also CD can be defined as disk. Okay. Now processor is how we know about those things. That is Pentium 1, Pentium 2, Pentium 3, Pentium 4, and now this i3, i5, i7, i9, and so on and so forth. And after that, peripheral devices, input and output devices. So peripheral devices comes that like keyboard, mouse, and scanner and printer. Those are the peripheral devices. So those are the parts of the computer system, and we called it as the hardware. Now, this computer hardware cannot do those things alone. So we need some instructions. To do some execution, we need some instruction. So that instruction is written as a program. Okay, and the process is called as a programming. So what is computer programming? The computer programming process of writing a program, just like that. What do you know? Want to do some addition or subtraction to a computer. Now, how to do that? You have to write a program. So that process is called programming. Now, computer programming. Uh, so computer software is written by computer programmers using programming language. So there are some language like what we discuss in C. We have Java. We have Python. We have also like PHP, HTML, and many more are present. So programmer writes a set of instructions which specific programming languages. Such instruction is known as source code. Okay. So we write some source code. That is the uh, first stage of any programming. So the programmer writes the source code. Now that one part of the programming language is known as compiler, which will execute the source code and it will transform into a language that the computer can understand. So the result is an executable computer program, which is also named for software. So that like computer games, driver software, education software, media players, different productivity softwares, operating systems, those are everything is a source code. Now there is a compiler inbuilt. That compiler compiles the data, compiles the program, and it will convert to the native language for the machine. Now classification of computer software. As I mentioned in the previous slides, that there are two types of software. One is application software, another is system software. So application software is specific, do some specific tasks, just like say suppose Excel or spreadsheet do some job related to the spreadsheet. He cannot do that music player job like music player, or he cannot do the cannot able to create and games, or we cannot browse web using Excel. So some software have particular application. So we are this PPTX is used for the PowerPoint presentation, not for web browsing. Okay. Similarly, Google Chrome or Firefox is used for uh, web browsing, not for PowerPoint presentation. So this type of things are there. So those are application softwares. Now system software provides a general programming environment, which is the programmers can create specific application suit their needs. Now this system software gives the programming environment. Now that Excel should run on Windows, the Excel could not run on Linux, or it could not be able to run on the Mac OS. There are different applications for them. Okay, for that particular, the same type of task can be done using different applications. So that application software is also a uh, OS dependent, and that OS provides an environment to run that application. Okay, so these are the main classification of the software. Now here in this chart we can see that what has been discussed in this previous slide. So application, programs, games, spreadsheet, word processor, database, or browser, these are applications. Operating system is the system software, and computer hardware, printer, mouse, scanner, keyboard, CPU disk, these are the part of the hardware. So hardware are always interacting with the system software, not with the application software, and the system software is the middle or the bridge between the hardware and the application programs or application software. Okay. Now there is a part which is known as BIOS. So BIOS is the term is basic input output system. So it's a de facto standard defining a firmware interface. So is de facto means is by default we can say that standard which is the firmware defining as firmware interface. So firmware is like that what we do, how the different components will run. Okay, so that has been written on this BIOS. So when the computer starts, the first function of the BIOS to perform the initialize and identify system devices such as video register card, keyboard, mouse, hard disk, DVD drives, and other hardware. In other words, the BIOS chip would runs a test called post power on self test, called power on self test, to ensure that system devices are working correctly. So that is the main function of this BIOS. So here these are different functions are mentioned. Initialize system hardware. The BIOS menu initialize system registers. Initialize power management system. It tests RAMs, tests all serial and parallel port. It tests external drives and display summary information. So this display system summary information actually in modern day system we cannot visualize this. But if you go to in our lab, some of the Windows XP systems are present. So there you can see this summary information when we restart the machine or when the machine going to start. So this summary information in that particular machines we can visualize. But here after Windows 7, we cannot visualize that thing. Okay, because that process very fast. And in earlier days, the processors are slow. So in that case, we can check the system summary information, the display counts. But here the display is going so fast that we cannot visualize. Now come to the operating system. That the operating system is to make the computer system convenient and efficient to use. Okay, so it supports the user to support the user application. The operating system is a system which can be used to help the one application to run properly, and it can also be useful uh, to manage different system resources for that application. So operating system has to manage the different system resources for any application. So means that say suppose you are using you are gaming with your PC. So in that case, that operating system has to control the amount of CPU and memory for your gaming. That has been controlled by the operating system, and that IO devices, it has been also controlled by that operating system. Okay, so we must utilize efficiently. So that has to be kept on our mind, that if there is an operating system, if there is some application is running, that the system the utilizations of the system resources must be in efficient manner. It is important for an operating system to have control policy and algorithm to allocate system resources. That must be written during the operating system own files. Now, some utility softwares are present, though these are not the uh, part of the application software. It is part of the operating system. Okay, and sometimes some applications required this utility software. Most of the applications do not require this utility software. Only GUI and command line interface must launcher applications. These are useful for any application software. You must have gone through the disk defragment, disk partitions, file managers, backup utilities, disk cleaners, network utilities. So these are the part of that systems. Okay, so it has been given with the operating system. Now come to that point. Two things. The one is compiler and the interpreter. So compiler is a special type of program that transforms the source code written in programming language, that is source language. In our case, the C is our source language, into the machine language comprising of just two digits, ones and zeros, the target language. So machine can only understand ones and zeros. So we need to convert our source code into the machine language, which is the target language. Now this combination of ones and zeros is known as the object code. So we have to convert a source code into object code. If source code contains error, then compiler will not be able to intended task. So error is called syntax error. So syntax error due to the compiler's error causes compiling errors. So such as this syntax error can be spelling mistakes, typing mistakes, etc. And this logic error cannot be understandable by the compiler. Okay. Now, interpreter. The interpreter is a compiler. The interpreter also executes instruction written in a high-level language, but here in this case, it does not directly convert to the machine-level language. It somewhere in between that language, intermediate form. We called it as an assembly level language. Sometimes we called it as an assembly level language. That means whenever we talk with some other persons of other countries, say suppose Russia. So in case of Russia, that particular person does not know English, and you didn't know Russian. So one interpreter required to convert. So you are also talking in source code form. That particular person is also talking in source code form, and the interpreter is converting the each source code to the native form. Okay. So this interpreter, so big advantage that does not need go through the compilation stage during the machine instruction is generated. The interpreter can immediately execute high level programs. That is the one of the advantages of the interpreter. Other are presents in part of in the programming language. One is linker, or we call it link editor or binder. A linker is a program that combines object module in the form of executable program. Suppose we have a different modules for a large program. So linker actually links between the create link between the each module, and that will be converted into an object code. And another is the loader. A loader is special type of program that copies program from a storage device to main memory where they can be executed. Most loader transfer to the user. Suppose some programs can be directly run from an pen drive. So that so we called it says sometimes we call it bootloader. So bootloader, we have a bootable pen drive. We called it as a bootloader. So that pen drive can boot uh, himself or herself, uh, okay, to any OS. So that bootloader, you must have to know the term. Okay. So next is application software. So an application software is a type of computer software that has been already discussed that employs the capabilities of a computer directly to perform a user-defined task. So we have defined one task. So that task can be executed by that application. To better understand the application software, consider an analogy where hardware depicts the relationship of electric bulb to an electric power generation plant of a system. So a system is an electric power generation plant, but an electric bulb is an application. Okay. So that analogy will be also applicable for any application software which is installed in any computer program. Typical example of software applications that has been already discussed. Now, stored program concept. So this earlier that instruction are stored in binary form, and processing start with the first instruction of the program, which is copied to control unit, and this instruction written the user performs sequentially until there is a break in the current flow. So von Neumann architecture, we called it as a von Neumann architecture. And the last one is that input, output, and processing operation are performed simultaneously while the data is being written in a central processing unit. Execute another program in the memory that is ready for execution. So a stored program architecture is a fundamental computer architecture where the computer executes the instructions that are stored in its memory. So that is the basic concept of this computer programming. So it can be asked in your exams that what is stored programming concept. So that has to be written properly. So this slides will be helpful. Now, programming language. A programming language is a language specially designed for express computations that can be performed by the computer, and there must be some express of algorithm or mode of human communication. Now, there are some high-level programming languages that are easy to human readable and understandable. Now, in between machine level and high level language, there is another language which is known as assembly language. That is difficult to understand um, a programmer, but it is better than that high level language. It is faster than the high level language. Uh, so, irrespective what language the programmer use, the program written using programming language has to be converted into machine language. So the ultimate objective is to convert it to the machine language. Okay, whether it is written in the assembly language, whether it is written in the programming high-level programming language. So assembly language, you may you may have go through that microcontroller programming. If you go through microcontroller programming, you must know that what is assembly language. If you don't go through that, you will come to the microprocessor and microcontroller programming in a few semesters. So in that particular subject, you will learn that assembly language. Now the question is, the programming language is best depends on the following factors. That is the type of the computer which is the programming executed, the type of program, the expertise of the programmer. So these are the all important factors are there. Also, another factor is that what type of problem we want to solve. So uh, for that particular problem, which programming language will be suitable. So that is also an important factor. So one problem can be solved in multiple programming languages. So in that case, we must have to be considered that which one is efficient, which one is less time consuming, which consists which contains less memory, all the things. The advantages, which one is advantageous for that particular program. So that has to be also measured. Now, the first generation computers in 1950s, which is written in the machine language, what is the program is written in the form of machine language, and it is quite fast, but it is tough to utilize this machine language. Okay, for a larger problem. Now we come to the second generation language, which is known as assembly language. So in that case, we have some um, codes or mnemonics. We called some mnemonics are present, which is known as operation code and operands. These are there, and for move, add, subtract, and compare, there are some specific mnemonics are present there. Okay. In the next slide, so in this slide, so you have can see that MOV stands for move, MOV stands for move, ADD stands for addition. Okay. So in this form, this assembly language is written. So we need a translator. We call the needed translator, often known as assembler, to convert them to the machine language. So we need an assembler to convert them to the machine languages. Okay? And these are called mnemonics. Now come to the third generation language in which we are mainly working. So these 1960s and 70s, it is English-like manner, written in English-like manner, and it's convenient to the programmer uh, to solve any particular problem. Those are Fortran, Pascal, COBOL, C++, Java, Python, so coming. So these are the third generation high-level programming language, 3GL. Now there is also very high-level programming which is called fourth generation programming languages. So these are that some instructions written in English like sentences. These are non-procedural. Okay, those earlier third generation languages are procedural. There are some procedures are there, but in this case these are non-procedural. Also, it is better, far much faster than the third generation languages. Uh, like that we have a table of table file enrollment, sum of students semester by class. This can be done in one or two lines. There are some database also required, and we have to we have to do some queries on the database. And now there are some efficiency is much less on machine resource efficiency is much less as compared to the third generation languages. Okay, that is one of the downside of this particular fourth generation languages. And also there are fifth generation languages which is mainly used for artificial intelligence research like Prolog, OPS5 and marketing. We don't have any idea about these languages. I don't go through these languages. So also there are another language, Visual Basic, that is one of the older language. This is also a fifth generation languages. So it is used to control the visual tools for any particular program. Now, design and efficient implementation of the program requires has to be done by this programmer. Okay, the programmer has to perform various activities that need to be performed during development process. So this is the programming life cycle or software development life cycle. So we have to consider the requirement and we have to analyze that. And then based on the analysis, we have design. Now go to the implementation of that particular design. Now after that we go for testing. So that testing is an important part of any software development. Now after testing, successful testing, we go for deployment, training, and support systems are also there, and one has to maintain the software also. Okay, so the developer itself goes for the maintenance of that particular software. Now program design tools. There are three uh, parts of the program design tools: algorithms, flowcharts, and pseudocodes. So algorithm provides a blueprint to write a program to solve a particular problem. So we write an algorithm of a finite number of steps. Okay. So step one, step two, and so on. So we in define different procedures for any program. The flowchart is the graphical representation of that algorithm or that steps, also which relates to different processes. So that is known as the flowchart. And pseudocode is a compact and informal high-level description of an algorithm that uses structural convention of any programming language. So pseudocode pseudocode is a high-level description of an algorithm. Okay, it is not like a flowchart, but it also not an algorithm, but it is quite uh, high-level description of that algorithm. Okay, so we use for structural conventions of any programming language. Now there, whenever we designing or making some programs, there must be some errors will be there. So what type of errors? There will be runtime errors, there will be compile time errors, there will be linkers error, there will be logical errors. So logical errors can only be understandable whenever we do the programming. Runtime error and compile time error whenever we run a program. So in that time it will generate. We first compile, then compile time error, then we run the program. A linker error means that a linking of different programs. There will be some linkers error will be there. So the linker error is for any large amount of task. Okay. So whenever a huge uh, length of programming is there. Now there are some testings there. So unit test, we have integration test, we have system test. So this test and this can be done at the development end for developing a software. So up to this, we have discussed the basic concept of programming. I hope you have understand overall. Though I have discussed in the classes before, still some of you are not present in that classes. So I will request you all to go through these video lectures and try to understand. If you have any queries, you can ask me anytime. Thank you.